During the video presents a detailed view of the complex logistics and engineering required to move a massive mounded bullet storage tank, a large cylindrical pressure vessel commonly used for storing liquefied gases such as LPG or other industrial gases. Because of its enormous size, extreme weight, and strict safety requirements, the entire operation demands precise coordination between engineering teams, transport specialists, and safety personnel. At the beginning of the process, the mounted bullet is carefully prepared at the fabrication or staging site. All connection points are secured, protective covers are installed, and the structure is inspected to ensure it can withstand the stresses of transportation. Since these vessels are designed to operate under high pressure, even minor structural damage during handling could lead to serious safety risks. The core of the operation involves a specialized multi-axle transport system. The video highlights the use of a heavy-duty modular trailer equipped with numerous axles distributed along its length. This configuration is essential for evenly distributing the immense load of the cylindrical tank, reducing ground pressure and ensuring stability during movement. Each axle line can often be independently controlled, allowing the transport vehicle to adjust its height, steering angle, and suspension response in real time. Once the mounted bullet is securely mounted onto the transport platform, extensive checks are performed. Engineers verify load balance, fastening integrity, and clearance conditions. After approval, the convoy begins its slow and highly controlled journey. Due to the oversized nature of the load, the transport often requires road closures, escort vehicles, and route planning that avoids sharp turns, weak bridges, or low-clearance structures. During movement, constant monitoring is essential. Operators track the behavior of the load, ensuring that vibrations, tilting, or shifting do not exceed safe limits. Communication between drivers, escorts, and control teams remains continuous throughout the journey. The video emphasizes that transporting a mounted bullet is not simply a logistical task, but a highly engineered operation combining mechanical precision, safety management, and real-time coordination. The successful relocation of such a massive storage vessel demonstrates advanced heavy transport technology and the capability of modern engineering to handle extreme industrial challenges. At the Drummond coal mine in early 2017, a remarkable heavy haul operation took place as a large hydraulic excavator was prepared for transport across the vast mining terrain. The video documents the carefully organized process of moving this enormous piece of mining equipment along a wide dirt road within the mine site. The excavator, built for high-capacity coal extraction, dominates the landscape as it moves slowly under strict coordination of specialized transport teams and support vehicles. Its massive structure is clearly visible when compared to the surrounding workers and smaller utility machines, emphasizing the extraordinary scale of modern mining technology. Throughout the operation, safety and precision remain the top priorities, with escort vehicles guiding the route and ensuring the stability of the transport process. The road conditions inside the Drummond mine are wide but uneven, requiring constant adjustments as the massive excavator is carefully guided through the mining corridor. Support crews continuously monitor every movement, ensuring that the machine remains balanced while navigating the long haul route toward its designated working area within the mine. This careful relocation process reflects the complexity of modern open-pit mining, where heavy machinery must be frequently moved to optimize production efficiency and resource extraction. At every stage,
Operators maintain constant communication to coordinate speed, direction, and spacing between the excavator and its accompanying convoy vehicles, ensuring smooth progress across the mining site. The sheer size of the machine makes this transport operation a challenging engineering task, requiring meticulous planning, reinforced logistics, and highly skilled operators to execute the movement safely and efficiently. As the excavator progresses along the dirt highway within the mine, it symbolizes the scale of industrial power and the importance of efficient resource transportation in large-scale mining operations. The scene captures both the raw power of the machine and the precision required to handle such enormous equipment in a controlled mining environment. Ultimately, this transport operation highlights the advanced engineering capabilities that support the coal mining industry and the careful coordination required to move such a massive hydraulic excavator safely across the Drummond site without incident or disruption to operations' overall mission success.
The operation shows the extraordinary transport of a massive hydraulic mining excavator across challenging terrain in Colombia. The machine being transported is the Komatsu PC8000 hydraulic excavator, weighing approximately 700 to 800 tons, one of the largest mining machines in the world. It is manufactured by Komatsu, a global leader in heavy mining equipment production. The transport operation is conducted by Transportes Montejo, a specialized heavy haulage company in Colombia. The journey covers approximately 25 kilometers through difficult roads, requiring careful planning, road reinforcement, and continuous coordination with safety escorts. The convoy includes multi-axle trailers, hydraulic modular systems, and powerful prime movers designed to distribute the enormous weight evenly. Due to the size and weight of the excavator, bridges, curves, and terrain constraints require slow movement and constant monitoring. Overall, the project demonstrates advanced engineering capability and logistical precision in moving ultra-heavy mining equipment over long distances. This remarkable relocation highlights the coordination between engineering teams, transport specialists, and local authorities, ensuring the safe delivery of critical mining infrastructure to its destination, despite extreme logistical challenges along the route successfully completed. Sophisticated route surveys, temporary infrastructure adjustments, and escort vehicles were essential to maintain stability and traffic safety throughout transport operations during transport operations. The video shows a complex and highly coordinated recovery operation carried out after a serious accident involving a heavy-duty mobile crane, an XCMG 25K crane. The machine had overturned and was left resting at an unstable angle on soft ground, creating a dangerous situation that required precise planning, heavy lifting expertise, and strict safety control. At the beginning of the operation, the overturned crane was carefully assessed by the recovery team. The ground conditions, the tilt angle, and the load distribution of the damaged machine were all analyzed to determine the safest lifting strategy.
Because of the massive weight and awkward position of the crane, a single lifting unit would not be sufficient to restore it safely. Any imbalance could cause further damage or even a secondary collapse. To solve this problem, the team deployed 2 auxiliary heavy cranes working in synchronization. These supporting machines were positioned on stable ground at carefully calculated distances from the overturned XCMG crane. Rigging specialists attached multiple high-strength lifting slings and steel cables to key structural points on the chassis and boom frame to ensure an even distribution of force. Once all connections were secured, the 2 cranes began lifting simultaneously in a slow and controlled motion. The coordination between the operators was critical. Each movement had to be synchronized to prevent twisting or sudden stress on the damaged structure. As the cranes gradually increased tension, the overturned machine began to shift slightly, indicating that the weight was being successfully redistributed. Step by step, the crane was lifted away from the ground. The recovery team used stabilizing lines to prevent swinging and to guide the structure as it rotated back toward an upright position. Communication between all crew members remained constant throughout the process, ensuring immediate adjustments whenever needed. After several careful lifting stages, the XCMG 25K slowly passed its tipping point and rotated back onto its wheels. The moment it regained vertical balance marked the most critical phase of the operation. The auxiliary cranes continued to hold it steady while technicians checked for structural damage and confirmed stability. Finally, once the crane was fully secured in an upright position and stabilized on its own chassis, the supporting cranes gradually released tension and were disconnected. The successful recovery demonstrated the importance of teamwork, precision engineering, and the effective use of multiple lifting systems in heavy rescue operations.
A road train crosses Cahill's Crossing over the East Alligator River in Australia's Northern Territory, while crocodiles watch closely. The tide flows over the crossing, bringing fish that the crocodiles feed on. Other footage shows them catching and eating fish in the river below them. The video shows the transportation of oversized components for the Ituango hydroelectric project in Colombia, one of the largest energy infrastructure developments in South America. In the scene, a heavy-duty red tractor trailer carefully carries a massive cylindrical structure along a construction route. This large steel component is part of the hydroelectric installation system, designed for water conduction and energy generation inside the underground powerhouse. Because of its extreme size and weight, the transport requires specialized multi-axle trailers, precise driving control, and strict safety coordination along the route. The operation highlights the engineering complexity of the Ituango project, where every component must be delivered under controlled conditions to reach the dam and cavern facilities safely. This logistical process plays a crucial role in assembling the turbines and hydraulic systems that will eventually generate electricity for millions of people. This video shows the transport of a 26-ton excavator up a steep 1,800-meter mountain road using a 6x6 truck with a low-loader trailer. The most challenging part is a very tight hairpin bend, where maneuvering is extremely difficult. From the outside, it may look possible to take a wider line, but the edge of the road is very soft and unstable, making it extremely dangerous. A small steering mistake could cause the vehicle to slip and fall down a deep slope. Because of the terrain, four-wheel drive is activated to pull both truck and excavator safely uphill. The video presents the operation and transportation capabilities of a 4-track snow and swamp transporter, model TS-Z. This specialized heavy-duty vehicle is engineered for extreme terrain conditions where conventional transport equipment cannot operate effectively, such as deep snow, marshland, wetlands, and soft ground. In the scene, the transporter demonstrates its mobility and stability while carrying out logistics tasks in a challenging environment. The 4-track configuration is the key feature of this machine, allowing it to distribute weight evenly across a wide surface area. This minimizes ground pressure and prevents the vehicle from sinking into unstable terrain. As a result, the TS can move safely across areas that are otherwise inaccessible. During transportation operations, the vehicle is typically used to carry equipment, cargo, or personnel to remote locations. Its robust chassis, powerful engine, and reinforced track system ensure reliable performance even under harsh weather conditions. The design also emphasizes traction and control, enabling smooth movement over snow-covered slopes and muddy ground. Overall, the TS Snow and Swamp Transporter is a highly specialized solution for Arctic, subarctic, and off-road logistics. It plays an essential role in supporting construction, exploration, and supply missions in regions where infrastructure is limited or non-existent. The video presents a detailed look at the complex logistics involved in transporting a massive industrial cargo across continents and through multiple transport systems. The operation begins in Shanghai, where the oversized industrial shipment is prepared for international export. Due to its extreme dimensions and weight, conventional transport methods are not suitable, so a carefully planned multimodal strategy is required. The cargo first travels by barge from Shanghai, China, through major international shipping routes toward Europe. This maritime stage is essential as it allows the heavy equipment to be moved efficiently over long distances while avoiding the limitations of road and rail infrastructure. The shipment arrives at the port of Antwerp, one of Europe's largest and most important logistics hubs. At this stage, the cargo undergoes handling operations involving heavy lift cranes and specialized port equipment designed for oversized freight. After customs clearance and reconfiguration for inland transport, the load is transferred to a specialized convoy for road transport. The journey continues from the port area toward Frouard in France. This phase requires precise coordination as the convoy must navigate public roads, bridges, and urban infrastructure while maintaining strict safety protocols.
Escort vehicles, route planning teams, and temporary traffic management systems are deployed to ensure safe passage. From Frouard, the convoy continues its final leg toward Varangéville, located in the Varangéville region of Lorraine in northeastern France. The transport route passes through the broader Lorraine area, where infrastructure constraints and local road conditions require continuous monitoring and adjustments. The convoy's movement is slow and deliberate, reflecting the immense size and value of the cargo being transported. The entire operation highlights the precision and coordination required in modern heavy logistics. It demonstrates how international supply chains integrate sea transport, port handling, and specialized road convoys to deliver industrial equipment safely across continents. From Shanghai to Antwerp and finally into inland France, every stage is carefully engineered to ensure efficiency, safety, and structural integrity of the load. This convoy exceptionnel is not just a transport operation, but a showcase of engineering logistics at a global scale, where timing, planning, and technical expertise all come together to move extraordinary industrial cargo successfully to its destination.
The video presents a detailed view of how extremely large and heavy industrial machinery is moved safely across public highways from an assembly site to its final destination, typically a mining or industrial operation area. This type of transport is a highly coordinated engineering and logistical process that requires careful planning, specialized vehicles, and strict safety control. The equipment being transported is far beyond standard road limits in both size and weight. Because of this, conventional trucks cannot be used. Instead, multi-axle modular trailers, heavy-duty low-loaders, and hydraulic platform systems are deployed to distribute the massive load evenly across the road surface. These transport vehicles are designed to handle extreme pressure while maintaining stability during long-distance movement. Before the transport begins, a full route survey is carried out. Engineers and logistics planners analyze road width, bridge capacity, turning radius, overhead clearance, and ground conditions. Any obstacles along the route, such as traffic signs, power lines, or narrow intersections, are identified in advance. In many cases, temporary road modifications or reinforcements are required to ensure the safe passage of the convoy. A key feature of this operation is the presence of a dedicated escort and security team. From the moment the equipment leaves the assembly site, it is accompanied by trained personnel who manage traffic control and ensure public safety. Escort vehicles are positioned in front of and behind the convoy to warn other road users and prevent accidents. In some sections, police assistance may also be involved to temporarily close roads or redirect traffic. The movement of oversized equipment is extremely slow and controlled. The convoy often travels at low speeds to maintain balance and reduce stress on both the transport system and road infrastructure. Communication between drivers, escort leaders, and traffic coordinators is continuous, ensuring that any unexpected situation can be handled immediately. Special attention is given to bridges and intersections, which are among the most critical points in the journey. In some cases, traffic is completely halted while the convoy crosses a breach to prevent dynamic load stress caused by moving vehicles.
At intersections, tight steering coordination is required to navigate long and rigid transport combinations safely. Weather conditions also play an important role. Transport is usually scheduled during favorable weather to avoid risks caused by rain, strong winds, or reduced visibility. Wind, in particular, can significantly affect the stability of tall or wide loads. Overall, the transportation of oversized heavy equipment via public roads is a highly organized and safety-focused operation. It demonstrates the importance of engineering precision, teamwork, and strict regulatory compliance. Through careful planning and professional execution, massive industrial machines can be delivered safely from manufacturing or assembly sites to remote operational locations, such as mines, enabling large-scale industrial development projects to proceed efficiently.